So today I want to introduce you to this theorem called the triangle midsegment theorem. Again, using the word theorem, right? So this is not a postulate. This is not like a single item like a letter. This is, something that's been built on other math, right? And so we can see that as we're going to work through this. You're going to see we're going to use some other types of math to kind of work through this problem. Good night. What was that? All right. Okay, let's start. We got to get a triangle on our paper, so follow along, please. I want you to put a point. We're going to call point A at -2, +1. Point A at -2, +1. Point A goes at -2, +1. So that's right here, and then we'll label it A at -2, +1. All right, point B goes at -2, 7. Point B goes at -2, 7. So still -2, 1, 2, 3, 4, 5, 6, 7. And we'll label that as well, point B at -2, 7. -2, 7. Point C goes at 6, 1. +6, +1. Point C goes at 6, 1. So 1, 2, 3, 4, 5, 6, and up 1. And that's point C at 6, 1. And then go ahead and use your rulers to make triangle ABC. All right, so we have triangle ABC here. Now, this idea of a mid-segment, this triangle mid-segment theorem, okay, mid-segment, let's just think logically for a second. Mid, middle, segment, line segment, that means it's got two endpoints, straight path, right? So we're looking for a straight path that connects middle points. That would be a mid-segment, all right? Now, there is some math that we can do that helps us find middle points on a line segment, especially when we're working on a coordinate grid. That math is called the midpoint formula. We're gonna use that over here in just a second. So I want you to jot this down. This is the midpoint formula. And all a formula is in math class is just, hey, look, we figured out a way to do a shortcut that works all the time. That's what we come up with. All right, so here's the idea. If we have a line segment that stretches from A to B, and we want to find the middle of that line segment, we can actually do it mathematically using the addresses of the endpoints. And the way it works is like this. I'm going to do some big parentheses here like this for an ordered pair, X and Y, right? And to find the X coordinate of the middle of that line segment, what we do is we take these two X values, we add them together, and we find their average. It's going to look like this. Watch. We're going to say, we'll take the two X values, X2 and X1, and we're going to divide them by 2. This is the formula. Okay? And when we say X2 and X1, we're just talking, an X value from the second ordered pair and an X value from the first ordered pair. You've seen stuff like this back in algebra when we talked about slope formula and those kinds of things. Okay? So for the X coordinate of the midpoint, we're going to do the two X values, add them together and divide by 2. And for the Y one, it's the same thing. So it's going to be Y2 plus Y1 divided by 2 as well. So let's do this. We're going to try to use this formula algebraically to come up with the middle of line segment AB. But let me ask you this. Do you think you could figure out the middle of line segment AB without having to do all this algebra? If you think you can, put a point where you think the middle of line segment AB is. Go ahead, do it right now. Put a point where you think the middle of line segment AB is. If you're working in pencil, then you can erase it if you're wrong. Okay, now let's see if we can verify that using the midpoint formula. Okay, what you think the middle is, you found the middle, I think the middle is here. Now let's see if you're right. Okay? So here's how the midpoint formula works. Watch, I'll show you. Because you're actually gonna do this on your own here in just a second. So follow along. So we're going to start with the two x values, and it doesn't really matter what order you choose from as long as you're consistent. If you start with the b, start with the b for x and y, and so on and so forth. So we're going to do this. We're going to go -2 plus -2 divided by 2. So I'm taking the two x coordinates and I'm dividing by 2. And then I'm going to take the two y coordinates, 7 plus 1, and I'm going to divide that by 2 as well. And then I'm just going to do some math and figure this stuff out. So -2 plus -2. That's I borrowed $2 and then I borrowed $2 more. That means you owe $4. You're down $4, right? So in that particular case, it's going to be -4 divided by 2. And then over here, 7 plus 1, that's just 8 divided by 2. And then if I simplify these fractions, that's going to give me -2 and +4. And that should be the midpoint of line segment AB. So let's see if it's right. We'll figure it out. So -2, +4. Where's -2, +4? Well, if I start at my origin here and I go -1, 2, and then +1, 2, 3, 4, this right here, we'll call that D. That's the halfway point on line segment AB. How many of you got that right without doing the algebra? Okay, good. It's pretty easy, right? I mean, when you've got a nice up and down line, it makes it very easy to count, right? Look, 1, 2, 3, and 1, 2, 3. Clearly, that's the middle of that line, right? And so when we have, you know, vertical lines and horizontal lines, it makes it pretty easy to find the midpoints, right? Like, for example, why don't you put a point for the midpoint of AC? Go ahead and find the midpoint of AC. You should be able to do this without the algebra. So, of course, the midpoint for AC is right here at 2, 1. We'll call that E. And again, you can see, look, that's 1, 2, 3, 4, and 1, 2, 3, 4. Clearly, that's the halfway point of that one. Here's the problem that we run into. What happens when we don't have nice, neat, horizontal or vertical lines where we can count? Because we can't count 1, 2, 3, 4, 5 like that. We've talked about that before, because while this distance is 1 and this distance is 1, this distance right here is not 1. We can't count from here to here and go 1, 2, 3, 4. That's not 1. It's actually the square root of 2. And we'll talk about why that is that, but it's a different distance. Across the diagonal of that 1 by 1 square, this is the square root of 2. And it actually goes back to something called the Pythagorean theorem, which we're going to look at today. You're going to need to know really well, and you were actually introduced to in 8th grade. Okay? So we'll refresh your brain on that, because you're going to be using that quite a bit coming up in the future as well. So this is kind of a good opportunity for us to introduce this idea. But with that being said, we need to find the midpoint of line segment BC. Since we can't just count how long it is, we got to find the middle of the road. Do you think you could take a guess, though, where it might be if you look at the picture? Okay, take a guess where you think it might be, and then let's use the midpoint formula to see if that actually works to our advantage. I kind of set this up so that it works for you, okay? All right, here's what I want you to do. Up here in the top part of your notes, I want you to write midpoint BC, and then I want you to use the midpoint formula just like I did over here. Whoops, wrong pen. I want you to use the midpoint formula just like I did over here to see if you can find the ordered pair for the midpoint of BC. You go ahead and do that now. Okay, you find the midpoint using this formula. See if you can do it. I'll give you a little checkpoint. You should have set your midpoint formula up to look like that right there. You take the two x values, you add them together, divide by 2. You take the two y values, add them together, you divide by 2. Again, integer math I borrowed $2. I have $6. I can pay off my debt, and I still have money left over to go get lunch. I have a positive 4 left over, $4. And then, of course, you reduce that down, and you come down to 2, 4. So this should be the midpoint of BC. And if we check it out, starting at our origin, positive 2, positive 1, 2, 3, 4. Look at that right there. Did you guys guess at this point right there? Yeah, and that was pretty obvious. It looked pretty good, right? Well, that's because I set this up specifically. But if I take this triangle and I turn it on its corner A at all, if I rotate this 20 degrees, all of a sudden all 3 of these lines don't become as easy to find the midpoint. That's when you actually have to use this formula. And you will be expected to do that when we get to our quadrilateral. So I wanted to kind of introduce this idea of this midpoint formula to you because we're talking about midsegments. Okay, so midsegments. All right, let's in fact let's jot this down. We're gonna kind of take some notes here as we go along. But down here we're gonna say let's title this up the midsegment theorem. And we want to just kind of lay out what a midsegment is. So a midsegment is a line segment that connects the midpoints of 2 sides of the triangle. So just so that we can be clear on what a midsegment is, it's a line segment, right, straight path, 2 endpoints, that connects the midpoints of 2 sides of the triangle. So really what we have here is 3 midsegments. So let's draw those out with our ruler, okay? And this is where I'm going to switch colors up here. If you wanted to do a different color, you could do a different color here. But one midsegment would be segment DF. That would be a midsegment. It's a line segment that connects 2 midpoints on the triangle. Another midsegment that exists in this triangle would be from F to E. That's also a line segment that connects 2 midpoints. And the third midsegment would be from D to E, like that. Okay, now, let's see. I'm going to shade this in just a little bit. Let me go kind of to sort of a highlighter-ish kind of mode. All right, so I just want to sort of kind of get a little shading going on in here, just so that we can see this interior triangle that I did there, okay? Let's see, where do I want to write that? Okay, so what we're going to do is right here, we're going to say, we're going to kind of draw an arrow going up here, pointing to that, and we're going to call that the midsegment triangle. That's the midsegment triangle. All right, so you can see when we connect the 3 midsegments throughout the triangle, we end up with a triangle inside of the triangle. It's embedded inside of it. And this is what we call the midsegment triangle. Now, there's some markings that we want to make on our triangle here to kind of help us understand some things about this, okay? First off, because we know that D, E, and F are midpoints, we now know that DB is congruent to DA. And we can actually figure out exactly how long those are because it's easy to count, right? Like, you know, DA is 1, 2, 3 units long, and so is DB, 1, 2, 3 units long. That was a midpoint, so that cuts those into 2 congruent parts, right? Okay. At the same time, we can also say that AE is congruent to EC. And I'm using 2 markings because those aren't the same as the first single markings, right? You can see that this is 1, 2, 3, 4 units long and 1, 2, 3, 4 units long. And because we used the midpoint formula to find point F, we could actually say, even though we don't know what the measurement necessarily is right off the bat of B to F, we can say that from B to F is going to be congruent from F to C. And as I mentioned to you earlier with this whole Pythagorean theorem, the vertical and the horizontal distance, this diagonal distance across from corner to corner, is actually longer than those. And so we can use a different congruency marking, a third congruency marking. Okay, so some things that you need to know about midsegments that are going to help you with these types of problems as they're related to them, okay? Number one, the first thing that you need to know, and we're going to put this down here on our notes, is that the midsegment is parallel to the third side of the triangle. And we're going to clarify what that means. The third side would be the side it doesn't touch. So the midsegment is parallel to the third side of the triangle, and that's the side it doesn't touch when I say the third side of the triangle. So we said that a midsegment connects two sides of a triangle. So then the third side that it's not touching, it's always going to be parallel to. So if we put some parallel markings up here, like for example, let's take side DF here. We could put a little parallel arrow here on DF. And we know that DF is parallel to AC, because that would be the third side of the triangle, right? You can see that DF connects the midpoint on these two sides, this side of the triangle and this side of the triangle. That means that the third side is the side that's parallel here. Now that's important for us because once we have parallel lines, think about it. This is a parallel line. This is a parallel line. We know that because they both run horizontally on the coordinate grid. That's easy to see. But this now becomes a transversal. Oh, now we know angles. Now we have alternate interior angles, which are congruent. We could have corresponding angles. And by the way, our next unit is on quadrilaterals, and we're going to be studying parallelograms. And guess what's buried in this picture right here? So, see, this is all connected. Okay, and this is why I'm introducing this to you here in this setting today, okay? All right. Now, let's mark some other parallel markings on here. So we know now that line segment EF, we'll do two parallel arrows here. That's going to be parallel to line segment AB. So we'll do two parallel markings here. And we'll get more into exactly figuring out how we can know for sure that DE is parallel to BC. These two lines are also parallel. DE and BC are also parallel, and we'll mark those as well. But we'll get into that when we talk about our parallelograms and how to know that for sure. So let's put three parallel markings on this one. 1, 2, 3. And we need to keep these different because they're all not parallel to each other. That's why we have to have more markings on here. And we'll put the 3 up here. 1, 2, 3, like that. Okay, so the three midsegments, midsegment DF has a parallel partner, the third side. Midsegment EF has a parallel partner, the third side. And midsegment DE has a parallel partner, the third side. It's always the third side that they're parallel to. Okay, that's one really important piece of information about midsegments. So, like for example, if I didn't tell you that this was a midsegment, but I gave you this triangle and it had these markings on it, the expectation would be for you to know, well, hey, listen, if this and this are congruent, then that means that this is the middle of the line. And if it's the same markings over here, then that means I have a midsegment. Then that means I know that these lines are parallel. Those are all the inferences that you have to be able to draw from the markings on the triangles. You catch what I just did there? Okay, you got to be able to pull that information out. Now, there's one other thing that's kind of interesting about the midsegments. Let's jot this down. So the second thing that we want to say is that the midsegment is always half of the length of the third side. So the side that the midsegment is parallel to, not only is it parallel, but it's always exactly half as long. The midsegment is always half the length of the third side. Let's see it on the picture, again up here. Okay, we'll use the obvious one, DF. How long is DF? Well, DF is 1, 2, 3, 4 units long, right? Okay, DF is parallel to AC. AC is 1, 2, 3, 4, 5, 6, 7, 8 units long. 4 units long, 8 units long. It's parallel and exactly half its height, or length. And height-wise, look, we could look at 1, 2, 3 on EF, and 1, 2, 3, 4, 5, 6 on AB. Now, the question is can we say that this is exactly half of this? Well, if it's a midsegment, then that holds true. But you're going to actually be asked to have to prove that eventually, and that's actually done with this Pythagorean theorem. So I wanted to take just a couple of minutes to quickly review over Pythagorean theorem, because you're going to see this again. All right, Pythagorean theorem says this. First off, we're dealing with a right triangle. And in this right triangle, we want to know how tall, how long, and what is this length right here. And each one of these parts of the right triangle have a name. This is called the leg, this is called the leg, and this is called the hypotenuse. You guys remember hearing these words? Leg, leg, hypotenuse? Well, hopefully you remember hearing these, okay? And let's just jot down the Pythagorean theorem. We'll kind of squish this in down here at the bottom of our notes. You can actually do, like, if you want to do a little squiggle through here. It's like this, Pythagorean theorem. And this is the one, if you recall, it goes like this. A squared plus B squared equals C squared. Hopefully you recall seeing that. And we'll look at that in a little bit more detail as we move forward. But if we wanted to figure out, this lets us figure out lengths of sides of right triangles. It only works with right triangles. This A squared plus B squared. So the deal is that the A and the B are the two sides that meet to make the 90-degree angle. The C is always that diagonal side, that hypotenuse side. Okay, so if we were to try to figure out how long is line segment DE, what we would need to know is how long is AD and how long is AE. And those we can figure out really easily, right? Like AD, we can just count up 1, 2, 3. That's 3 units long. And AE is 4 units long. So if we know that, then we can set up a Pythagorean theorem. Watch, it works like this. We can go 3 squared plus 4 squared equals C squared. So we can say, all right, we know one leg is 3, one leg is 4. We're going to try to figure out what this one is right here. Okay, what does 3 squared mean as a multiplication problem? It's 9, right? It means 3 times 3, right? It's a number times itself. The exponent is how many ever number times, right? So then this is going to be 9 plus what? 16 is equal to C squared. And then what's 9 plus 16? Okay, we got 25. All right, and again, remember C squared, what this means right here is some number we don't know times itself. So then the question is what number times itself would give us 25?
5.
Yeah, 5, right? That's pretty straightforward, yeah? Okay, and by the way we actually ask that question in math class is with a square root operation. And we'll talk more about this. I'll review this with you guys as well. But this tells us that that side that runs from D to E is 5 units long. Okay? Now, let's see if we can figure out if that is actually half of this length right here. So to figure that out, what we want to do is we want to figure out, all right, how long is this? How long is this? And use the Pythagorean theorem to do this. So let's see if you can do that. All right? So over here on your notes, see if you can figure out how long is A to B, how long is A to C, and then use the Pythagorean theorem to try to figure out BC. See if you can do that right now. We'll just do that on your notes right down here. See if you can figure that out. I'll say it again. We want to know how long is AB, how long is AC, and see if you can use the Pythagorean theorem to figure out BC. See if you can do it. If you don't remember how to do this, this would be a good thing to polish up on. Maybe come see me. We can talk a little bit more about it. We'll do about a day on it, and that's about it for a refresher. About 5-6 minutes. We're almost done. Okay, so you should have, take a look. You should have set it up like this. You should have set it up like this. Because AB is 6 steps up, and AC is 8 steps long. So 6 squared plus 8 squared equals I don't know squared. Yeah. Okay, so what's 6 squared? Okay, 36, good. And what's 8 squared? Okay, good, 64, and I don't know squared. 36 plus 64? 30 plus 60 is 90, 6 plus 4 is 10, total of 100. So 100 is equal to c squared. C squared is some number times itself. Can you think of a number times itself that gives us 100? No, it's not 50. 50 times itself is not, it's not 100. 10, yeah! C equals 10, right? Okay, and again, that would have been done with the square root operation. But look, check it out. See, you can see it right there. You can see that those two sides are, the first side is exactly half of the other side. Okay, so even on the diagonal lines, we can use Pythagorean theorem on these right triangles to figure out that the midsegment theorem holds true on all 3 sides of this triangle. Okay?